Hello, Jeremy here. In this episode, we are going to do collision detection. I'm going to first start off with doing a image editor, so let's go ahead and pull that up. Alright. Okay. With collision detection, what it's about is determining if rectangles have collided with other rectangles. And since we're dealing with 2D objects, most things are going to be done with rectangles. You can use other things to collision detect. You can also do it with circles. Those are actually the easiest. With a circle, I can show you real quick what it looks like with a circle. So the circle, you have the center of the circle, and you have a radius. If you have another circle and it's touching, you have another circle and they're touching, you have a center and then you have a radius. You can easily draw a line from here to here. As you add the radiuses together, and they're the same or less distance apart, you know they touch. They've collided with each other. So with circles, it's pretty easy. Let me see if I can get a circle that just touches. Whatever. I think you get the point. So if they're not touching, the distance between these points is greater than the sum of the both radiuses. So this is circle A, this is circle B. A dot radius plus B dot radius is, if they're colliding, they will be greater than or equal to the distance B. Lowercase. Oh no. Distance B. So this is D. So this is if they collide. So this is collision. Circles are really easy. If you could have all your collisions done with circles, this is all you need. However, most of our sprites are done with rectangles. Therefore, we need to do collision detection with rectangles. As such, you need to figure out if these rectangles are colliding. I'm going to use two different colors to do the explanation. So I'm going to use red for one rectangle and blue for the other rectangle. Okay. So here's the deal. We have an axis here, like so. This is the y-axis, and this is the x-axis. So the idea with collision detection is you want to find the overlap of these rectangles. So the easiest way that I'm aware of, I did not research this is just something I came up with, is you project it onto here and here. So you have a red line. And then we project the blue rectangle up to the x-axis. And you have a blue line. Red and blue make magenta in our color scheme, so where they overlap are this magenta. What we're trying to find is regions where there's overlap on the x-axis with this magenta region, and you want to find the projection on the y-axis. Dun, dun, dun. And then blue also projects over. Okay, and that's the blue region. This is blue. This is red. And they combine to make magenta. Those overlap here. So with collision detection, you need an overlap on the X, and you need an overlap on the Y. I'm going to draw some more images to show you if they're not overlapping on the X, and they're not overlapping on the Y, and they're not overlapping on either. Okay, let's draw the axes here. Make it easier on me. Okay, we have a red rectangle. Okay, so this will be non-overlap on the X. And when I draw it, it should be fairly obvious to see there's no overlap on the X. There will be overlap on the Y. All right, draw the projections up, draw the projections over, draw the projections up. No, undo. Yeah, these are super artsy, right? All right. Okay, so on the x-axis, there's absolutely no overlap. On the y-axis, there is no overlap here. Blue, that's red. And the same happens with the y-axis, as you can imagine. So I'll just do that. So having no overlap on the y-axis looks like this. So room. And draw it up, draw it up, draw it over, draw it over, up, up, over, over. And no overlap. I got some overlap there. Let's do the blue. No overlap. And we got overlap here. Okay, so this is the basis of the collision detection that I'm going to do. All right, the method that I'm going to use is this. We're going to have do this so we can say rectangle A. It's rectangle B. This is B dot X. This is B dot X plus B dot width. Okay. This is A dot X And this guy is a dot x plus a dot width. All right, we have overlap. If we have overlap in this region, if the x coordinate of is b dot x is in between a dot x and a dot x plus a dot w. So we could see that here. It's just saying if a dot x is less than or equal to b dot x greater than or equal to a dot x plus a dot w. So this is the first condition where we have overlap. And then other condition, or it's the same thing. It's b dot x less than or equal to a dot x greater than or equal to b dot x plus b dot w. Okay. This first expression is saying if the x coordinate is inside this range of the A's rectangle. So we're seeing if there's this point is existent anywhere within this range. So what we're looking for is in this one we're saying in this range here, is b dot x within this? So it's right here. So yes, that point right there. So that's what this statement is looking for. The other statement is the same thing, but with the B rectangle. We're looking for essentially if we flip A and B, this is what this is saying. This is the flip. All right, this detects collision for the x-axis. And we do the same thing on the y-axis. We just use y and height. It's the same idea. All right, I think I've described this algorithm good enough right now. So what I'm going to do is I'm going to implement this in code and see where it gets us. Okay, so let's pull open the editor. All right, let me get this tag out of my way. Okay. Editor. Gotcha. Oh, I got a message. Let me see. Okay. All right. Nothing important. That was work, so I had to check it out. Alrighty. What I want to do is I want to define a collision method. F collide rect. And this will take a rect called A and a rect called B. We're going to have to pull them into components. I don't believe the rect that Pygame uses has components. I don't think it does. Let's try it out. Yeah, let's try it out. So this is something, if you don't know what's going on, you try things out. Now, of course, I can't super evil. Of course. I didn't check on it beforehand. And it's not going to show up. Okay, I shouldn't play with that. Oh well, we're just going to assume that it won't work and go with another design. So I'm just going to make variables. I really don't like this, but it is what it is. A width, a height. There's A, same thing for B. Okay. And then this is going to be what we discussed. Well, we want to know collide x equals ax is less than or equal to bx and equal to ax plus aw. Gives us our collision. Collide y is the same idea, but width and height. Nothing but y and height. And we want to return if they've collided with x and they collided with y. So that tells us if our two rects have collided with each other. What this can be used for is we can put rectangles in the game, like sprites, and then have other rectangles like walls, pillars, barriers. And when we collide with them, they do things. Okay. What I'm going to do is make square become a little bit more collider, I guess. I'll use a square. Okay, def init, self, position, size, color, collision color. Okay, I'll go square dot init, and we'll pass in self, position, size, color. I'll create a square for us. Alrighty. Well, draw will be inherited. I'll write update self comma event self time. What I want to do is every tick we want to see if a square has collided with us, if another rect has collided with us. Or that we get the other square. We don't know. It's going to be in the world. I'm going to have to do it in the world. And I have to test for collision with every single rect. That is not itself. That could be expensive. I want to do this. I'm not sure how to do this at a very efficiently. The way I'm thinking is very inefficient. You pair off every object, every rectangle that you want to test, and you see if each one collides. So it's a permutation, which is a bit sad. It's a permutation of pairs, so what is that? N times n minus n times n minus 1, so it's close to n squared. Whatever, it's just inefficient. Okay. There's got to be a good way to do this. It's not here. I shouldn't do it like that. Let's do it in the main loop, and then we'll decide how we want to restructure things as time goes along. All right, we have a group here. We have a group of sprites. I want to make a fixed square. Let's make a square. And it's going to be a square class. And its position will be 0.00. Size, I believe it was a size, would be 2020. Now let's give it 100 as its position. I believe it just needs a color, so that would be white. 255, 255, 255. Square. QUARE. Backwards, please. Position, size, color. Correct. And then we put a square in there. Alrighty. Let's go ahead and pop up our Python program. Okay, there's a little square. Definitely see it on the little end of our stair. Oh, we could cover our stair with it, but no, let's do this right now. And you can see that it's strong on top. Interesting. I wonder if it maintains the order here. It might draw it in this order, so it draws the main character and then it draws a square. Let's increase the size to 64, which is the same size as our character, and this should be 0.64. And this will cover the stairs. And quote. That will need to be updated as well. I have to encapsulate this logic so it can make tile nets. Via class. So they can just read in the file and generate an image from the file. That could be another video. Okay. So when we draw a sprite, we should test if that sprite collides with other sprites. Sure, let's do that. Okay. Or right? There's a better way to do this. Let's have it draw. Import. You should show this. This is driving me nuts. There we go. Now it works. Okay. Other tools have this thing called permutations. And I can give it a list of things, and it'll give me a permutation of that list if I can use the right syntax. And use commas. So this is all the ways we can combine this list of numbers. And with repeating numbers, but not positions. You can give it and say, comma 2, that means pairs. This is all the way we can test the pairs. This is effectively what we want, but with the sprites. We want to pair off all the sprites and then test each sprite's rectangle. So this is what I'm going to do in the code. I'm going to create a list of permutations, and then we're going to collide. We're going to do collision detection with this list of permutations. And if you want, you can pause the video and prove to yourself that all the numbers, 1 combines with 2, 1 combines with 3, 2 combines with 1. And you notice it's actually repetition. So you probably don't want repetition. We want combination, I believe. Combinations. Yeah, that's better. So test 1 with 2, 1 with 3, and 2 with 3. We don't need to test the other way around because it would be the same thing. We'd be testing multiple times. So we're going to use this in the code. That'll make it more efficient. All right. Oh, for sprite A, comma sprite B, and iter tools dot combinations. This will be group dot sprites, comma 2. You can then go if collide, I think it's collide, right? Yeah. Sprite A dot rect, sprite B dot rect. And we notice that we will most likely want to put this collision detection inside the sprite class as well. And I do believe that there is in the sprite class that is with Python, there is collision detection built in. However, I wanted to go into what collision detection is and show it from the ground up. All right, now that we know they've collided, I want to tell each of them they've collided. So sprite A dot collided with sprite B. And sprite B dot collided with sprite A. Alrighty. So now we go back to the sprite class. Where are you? Okay. We're going to make a function called collided. And this will take a sprite as an argument. This will say what sprite has been collided with. Now we have an idea of what to do with what I wanted. Class. Did I get rid of it? Yes, you got rid of it. Okay. Class collider. Based off the square. Square. Def init. It's going to be repeat position. Size, color, collide, color, or collision color, square, init, self position, size, color. Self dot collision color equals collision color. Cool. Def collided. Great. Okay, so if this class is collided with another class, we want to change the color, which means we want to update the image. And self.image.fill collision color. And that will change the image color. Self.updated is true. Def draw self.updated is false. I don't think we need to do anything because this just updates the color. Should be it. Well, let's run it. I need to import iter tools. Okay. There we go. Oh, I need a self. Okay. Here's the error. Collided takes one positional argument, but two are given because I didn't specify a self. Okay, we will update. We will update. Self sprite. That should be good. How did I get that to happen? Wait, I didn't add a collided, did I? I don't have what I need. Oh, so well, so good. Oh, I want a collider. Just give me a collider, and I want it to be red. So let's turn it to red when it collides. The collider probably needs the same thing. Would be my guess. I got the same error, so rest assured that this is wrong too. Yeah. Collision color is not defined. Okay, let's see here. Collision color is not defined on line 141. There's no self here, so yeah. That will do it. Self.collision color. No, wrong program. Okay, so that touched, and we changed the color. That's good. However, notice something. When we run the program and we intersect down here, and it's fine. We don't test for collision. It's only when we do it here, so the link is lower, but not when the link is higher. No collide there, no collide there. But once the corner, the upper corner of links hit once it's here, that's really messed up. I don't know how the cursor is so messed up and so off. Anyways, you have to look at the OBS screen. So when the hitbox here crosses into the rectangle, it's fine, but it's not looking at this lower one, which is a problem. Okay. That means our collision function isn't working correctly. Because we're missing something. We're missing this. Bx is going to equal to Ax is going to equal to Bx plus Bw. Okay, and then we're missing the same thing on the bottom. These parentheses are not strictly necessary. I'm just using them to make it more clear. By is going to equal to Ay is going to equal to By plus Bh. Okay. Go ahead and try that. And it was instantly red because we were right by it and touching it. Okay, I'm going to move it down a bit. One 128, which is plus another 64. So move it down to the right another square. Therefore, it won't be touching the stairwell anymore. Okay, boom. Okay, cool. So that's collision detection. This is the basis of doing behaviors. Now we can detect if we can make a logic for link that if link collides, that we won't allow it to go through in the direction link is going. It will no longer allow movement, and that could be like for walls. And then there's other things you can do, like if you touch an enemy, that can hurt you, and things like that. So this is the basics for collision detection. We will later we will do collision detection for the walls, and then collision detection for traps. So that's the plan. I hope you enjoyed, and I hope to see you back. Have a good day. Bye.